Hello, in this video I'll be giving a brief summary of Unit 3. I will be covering Mod 6 and Mod 7 throughout this presentation. So to begin, we will start with Mod 6. Mod 6 is mainly about different types of graphs and finding ways to interpret them and find out their identifying traits such as spread and distribution. To first understand what this unit is, we need to know about different types of variables such as categorical, which includes things like sex and race. Here is an example of categorical data being used to measure students and their perception on their bodies. This can be put into a graphical display to be clearly understood. The other type of variable is quantitative, which includes numeric values such as height, weight, temperature, and others. There are a lot of different ways to display this, such as through histograms. Speaking of histograms, they are used to display frequencies of variables on a graphical display. There are many types of histograms, such as skewed left, skewed right, symmetric, and these all have their own reasons on why they look like that, having values that are more towards the lower side of things. There are a lot of qualities of histograms, like midpoint being the center of the histogram, spread being the range covered, and outliers being being points outside the general shape of the graph. Histograms are similar to stem plots, which display distribution of quantitative data. Flipping the stem plot will make it resemble a histogram, as you can see. Moving on, quantitative data has relationships that can be put on display using descriptions like shape, center, and spread. Measure of center is determined by mode, median, and mean, which can be calculated like displayed right now. It is important to note that mean and median, though similar, mean is extremely sensitive to outliers. Measure of spread can be visually different but have the same value. It depends on the distribution, and there are three different methods used to measure spread: range, IQR, and standard deviation. To start, range is fairly easy to find. All you need to do is take the min and max and find the difference between them. Interquartile range, or IQR, is how distributed the middle 50% of the data is. This can be found by splitting the data into quarters, and the middle two quarters will be the IQR range. IQR is most useful because it makes it easier to identify the outliers. The values found by IQR can be used to create a box plot, which uses the min, max, Q1 or quartile 1, median, and quartile 3 to display a 5-number summary on the dataset. Standard deviation can be used to quantify the average distance between data points and the mean. To get this, get the mean, subtract from all the values, square the values, and then add them together and divide by the number of values minus 1. Finally, you root the result. There are some rules that come with standard deviations, as you can see right now. And that wraps up Mod 6, and we will now move on to Mod 7. The first mod, Mod 6, was mainly about one variable, but most relationships include two, with both categorical and quantitative variables. Categorical and quantitative variables can be compared with each other using different methods. For example, categorical and quantitative would be something like hot dogs and the amount of calories. In this case, a box plot is used. Categorical and categorical variables do not typically use scatter plots of anything that will require numerical values. An example of categorical and categorical variables would be something like gender and body image. Quantitative and quantitative data or variables require different treatment than categorical and quantitative. One way to graphically display quantitative and quantitative variables is through scatter plots. Scatter plots can be described using shape, center, and spread. It is also important to note the direction, form, and strength of the scatter plot. Direction refers to the direction the scatter plot heads toward, such as positive, negative, or none at all. Form refers to the shape, of the scatter plot, like linear or curved. The strength for the scatter plot is how closely the data follows the form of the relationship. A strong form would seem almost as a line. Linear relationships sometimes occur when put into a graphical display. Tools used for linear relationships will not work when nonlinear relationships are used. The correlation coefficient, also denoted as R, is used in linear relationships to determine strength and direction. Correlation coefficient can also have some properties that are important to note. It will not change when the unit change. It will only work on nonlinear equations. It is not enough to determine whether an equation is linear or not, and is heavily affected by outliers. On scatterplots, regression is the line that shows the dependence of the response variable and the exponential variable. In the example, it is ideal to try to get half of the points on either side of the line. One last thing to mention is lurking variables and that association does not lead to causation, like the amount of firefighters responding to a fire and the damages in dollars. In this case, there is a lurking variable of seriousness of the fire. And that would conclude the presentation.